An ice age is defined by extended periods of reduced global temperatures and frequent glacial expansions, which can persist for hundreds of millions of years. Geologist Louis Agassiz and mathematician Milutin Milankovitch helped scientists understand that these ice ages are influenced by variations in Earth's orbital patterns and tectonic activities, which cause the glaciers to advance and retreat. Throughout Earth's history, there have been at least 5 major ice ages, with the last million years experiencing around a dozen major glacial periods. During the most recent of these glaciations, human populations evolved and adapted significantly, eventually becoming the planet's dominant terrestrial species, following the extinction of large megafauna like the woolly mammoth. An ice age involves cycles of colder global climates that lead to the expansion of glacial ice across Earth's surface, interspersed with warmer interglacial periods during which at least one major ice sheet is always present. Currently, Earth is experiencing an ice age, indicated by the presence of ice sheets in Antarctica and Greenland, which persist despite the planet's relatively moderate temperatures. These cooling phases start when a decrease in temperature across certain areas prevents snow from melting completely. Over time, the underlying layers compact into ice, forming glaciers that advance slowly due to the accumulation of more snow. This sets off a cycle where increased ice coverage traps more of Earth's moisture, allowing the ice sheets to expand and causing sea levels to drop as a result. How an ice age changes Earth. An ice age significantly alters the Earth's topography. As glaciers move across the land, they transport rocks and soil, carve out valleys and flatten hills, their immense weight causing the Earth's crust to sink. The drop in temperatures near these advancing ice masses forces vegetation adapted to colder climates to migrate towards equatorial regions. The substantial decrease in sea levels during an ice age allows rivers to deepen and expand their valleys, forming large inland lakes, while exposing land bridges that connect continents previously separated by water. When the climate warms and glaciers recede, they leave behind ridges of debris and depressions that, filled with meltwater, become new lakes, reshaping the landscape anew. Throughout Earth's geological history, scientists have identified 5 major ice ages. The Huronian, occurring from 2.4 to 2.1 billion years ago. The Cryogenian, 850 to 635 million years ago. The Andean-Saharan, 460 to 430 million years ago. The Karoo, 360 to 260 million years ago. And the ongoing Quaternary period, which started around 2.6 million years ago. In the last million years alone, there have been about a dozen significant glacial periods, with the most extensive glaciation occurring 650,000 years ago, enduring for 50,000 years. The latest period of glaciation, often referred to as the Last Ice Age, peaked about 18,000 years ago and transitioned into the current interglacial period, the Holocene, which began 11,700 years ago. During the last glacial maximum, ice sheets reached thicknesses of over 12,000 feet and covered vast regions, including Canada, Scandinavia, Russia, and parts of South America. This expansion of ice caused sea levels to drop by more than 400 feet and average global temperatures to decrease by approximately 10 degrees Fahrenheit, with some areas experiencing drops of up to 40 degrees. In what is now the Gulf Coast of North America, the landscape was populated with pine forests and prairies similar to those found in the northern United States and Canada today. Ice Age theory origins. The concept of ice ages and their causes has evolved significantly over time, starting when Europeans first noticed the retreat of glaciers in the Alps. The theory gained prominence largely due to the work of Swiss geologist Louis Agassiz in the 19th century. Agassiz challenged the prevailing flood theories of his time, which posited that a great flood was responsible for the extinction of large prehistoric animals like the woolly mammoth. Instead, he argued that the marks and debris left by glaciers indicated a series of prolonged, harsh winters or global winters had occurred. His observations of rock striations and sediment deposits linked these phenomena to past glacial movements rather than to a single catastrophic event. Further advancing the Ice Age theory was Serbian mathematician Milutin Milankovic in the 20th century. Milankovic aimed to reconstruct Earth's historical climate patterns by examining the past 600,000 years. His research, which culminated in the 1941 publication of Canon of Insulation and the Ice Age Problem, detailed how Earth's orbital variations, including eccentricity, axial tilt, and precession, impact the levels of solar radiation reaching the Earth. His theories were later validated in the 1960s through the analysis of deep-sea ice cores and plankton shells, which provided clear evidence of historical glaciation cycles. In addition to solar radiation, the role of plate tectonics in global climate changes is also significant. The movement of Earth's tectonic plates can alter continental configurations, significantly affecting oceanic and atmospheric currents. This tectonic activity can also lead to increased volcanic activity, which releases large amounts of carbon dioxide into the atmosphere, further influencing global temperatures and climatic conditions. Together, these factors contribute to the complex dynamics of global warming and cooling cycles, including the ice ages. How humans adapted to Ice Age's harsh climate. A key development during the last Ice Age was the evolution of Homo sapiens, who adapted to the cold environment by creating innovations such as bone needles for sewing warm clothing. They also utilized land bridges exposed during lower sea levels to migrate to new territories. With the advent of the warmer Holocene epoch, humans were well positioned to exploit the improved conditions, leading to advancements in agriculture and animal domestication. In contrast, many large animals that had thrived during the Ice Age, such as mastodons, saber-toothed cats, and giant ground sloths, became extinct by the end of the period. The extinction of these megafauna remains one of the enduring mysteries of the Ice Age, with theories ranging from overhunting by humans to widespread disease. Ongoing research into these periods continues to shed light on Earth's historical climate changes and provides valuable information that may predict future climatic shifts.